Application of the diode, this PN junction is very useful device. The main important application of the PN junction is as a rectifier. What is rectifier? Rectifier is a device which convert AC into DC. Now there is two type of the rectifier. The first is half wave rectifier. What is half wave rectifier? Half wave rectifier is the one which convert only half cycle of the AC. Remember, AC is like this. It is changing. In the time, it is going positive and negative. This is AC. So it is a device which work only for the half cycle and it don't work for the lower half cycle. Yeah, one half cycle it work, for other half it don't work. And such a device we call half wave rectifier. In the circuit of the half wave rectifier, the first thing is there is a transformer. There is a transformer. It is a AC source is connected to the transformer. This is the primary coil of the transformer. These lines shows the core, and there is another one secondary coil of the transformer. This is the transformer. There is a symbol of the transformer. Primary, core, secondary coil. Primary is connected to the AC source which is to be rectified. To the secondary, one arm of the secondary coil is connected to the PN junction diode. PN junction, the diode. And it is connected in series with a resistance we call the load resistance, and then to the another turn. So the PN junction is connected in series with the resistance load with the secondary coil of the, across the secondary coil of the transformer. Across the load we take the output. Now here load is nothing but whatever the device that you connect, across which you want to take. It may be your voltmeter, it may be a bulb, it may be a microphone. Now how it work? Here is an input AC. This is input AC. Now, for the one cycle of the input AC, say for the positive cycle of the input AC, here is an input AC. For the positive cycle of the input AC, say P side, this end is positive and this end is negative. This terminal is positive and the other terminal of the secondary is negative. So diode get forward bias. P positive and negative means forward bias. Diode will conduct. It will be just like a circuit on. The current will flow across the load resistance and we get the current. So whenever there is a positive cycle, we get the current. Now, in the negative cycle of the input AC, when terminal change, terminal potential across the terminal change, it become negative, the P side become negative, A end become negative, and say B end become positive, then the diode which was P side of the diode will be negative, N side will be positive, diode get reverse bias, and when the diode get reverse bias, no current. It has got just like an open circuit, no current. We don't get any current. In the negative cycle, there is no current. So what we observe, this is an output across load resistance. Positive cycle of the input AC, we got the current. For the negative cycle of the input AC, we don't get any current. So we get current only for half cycle of AC. Output is DC, is still fluctuating DC. It is a DC, but only for the half cycle of the input AC. So we call it half wave rectifier. Remember, these fluctuation in the DC, it will be, resultant will appear like this. So we'll get a wavy type of the DC. Not going in the negative, but in the positive only it is varying. These fluctuation present in the AC we call AC ripple. The component of the fluctuation present in the output is called AC ripple. Right? Now, full wave rectifier, as I told you that full wave rectifier is a rectifier which convert AC into DC, but this time it is for full cycle of AC. Last half wave rectifier, it was working to convert AC into DC, but only for the half cycle of input AC. When the cycle goes negative, that stops working. But this full wave rectifier will continue to work even for the negative cycle. Now how it works, but before let's see what is the circuit for it. Again, like half wave rectifier, it has got the transformer. Here how we make the transformer. There is a symbol of the transformer. Two coil, primary, secondary, and in between the two lines shows the core. It is step down transformer. To the primary of the coil, we connect AC, which is to be rectified. In the secondary of the transformer, we connect two diode, PN junction diode, across both of the terminal of the secondary coil, say terminal A and terminal B. We connect diode D1, we connect diode D2. Then, where is a load? We join them, and load is connected with the center tapping of the transformer. Here with the center of the transformer and with the center of this line, parallel to the both of the diode, in series with the both of the diode. RL is a load A and B across which we take the output. So load is in series with the diode D1 also, and the load is in series with the diode D2 also. C is a center tapping of the transformer. In between the coil we use the terminal, right? So this time we are using the 3 terminal of the coil. To the end terminal we are using the diode D1 and D2, and to the center terminal we are connecting the load resistance. Now how it works? For the positive cycle of the input AC, D1 become forward bias, and D2 is, because this side is negative, D2 will be the reverse bias. Remember, this is P, this is N. If it is positive, it is negative, it is forward bias. Conduct. If it is P, it is N. If this is negative, this is positive, it is reverse bias. It won't conduct. So D1 in the half cycle of input AC, D1 conduct and D2 become non-conducting. It got forward bias, it conduct. Now when it conduct, how the current will flow? The current will flow from A to D1 to the resistance, A to B, and back to the circuit. That will be the direction of the current. The current will flow this way in the upper half of the circuit across the load. In this half, there is no current flow. So we get the current across RL only for half cycle of input AC. It is just like this. Here we got the full wave of the input AC only for the positive half cycle. The diode D1 gives the current. We get the current output because of the D1. Now for the negative half cycle of the input AC. What happens in the negative half cycle of input AC? A become negative and B become positive. Now this time diode D2 conduct and D1 become non-conducting. Current flow only in the lower half of the circuit. And you check the direction of the current is anti-clockwise, but across the load resistance current is A to B only. Either it is due to the D1 or it is because of the D2. So for the negative half cycle, here is the negative half cycle. Now in the negative half cycle, D2 conduct and will give the current. But direction of the current will be the same, A to B, as it was because of the D1. So we get the current because of the D2. So positive half cycle, D1 conduct gives current. Negative half cycle, D2 conduct and gives the current. So resultant is we get the current for full cycle of input AC. We get the current for full cycle of input AC. And this time it is for full cycle, it is more continuous, but still fluctuating. The current is, our resultant current varies this way. This is our output, resultant output. It's almost continuously with fluctuation, of course, but less fluctuation. As we discussed, that output of the rectifier has got fluctuating DC. It is DC, but it is fluctuating. And these fluctuations we call AC ripple. These fluctuations are undesirable. We want a constant current, steady current, just like as we get it from the battery. To minimize the fluctuation or to remove the fluctuation, we use an additional circuit in the output, an extra circuit we need, and that circuit we call filter circuit, which minimize the fluctuations. Now there's a two type of the filter circuit. First is series inductor filter. Series inductor filter. In this case, what we do, here is our rectifier. To the rectifier circuit, we connect our inductor, a high value of the inductor. Inductor is a coil, inductance coil, and then we connect the load resistance. So before the load resistance, we connect the, and here we got the output. This we call series inductor filter circuit. Now what's the role of the inductor? We know that inductor has got the inductance XL is equal to omega L, that is 2 pi FL. So if there is an DC, then DC have got the frequency 0. So DC, for the DC, this inductor will not offer any resistance, and so the DC will pass, direct current will pass and will drop across the output. But AC, which has got the frequency say F, because of the frequency, the inductor will offer the resistance more than that of the DC, and so it will check the AC. Because of the frequency, the inductor will offer the resistance, and it will check the, it will offer the resistance, it will check the AC. So AC will be blocked over here. So AC will reduce, will not pass, and DC will pass and will drop across the RL. So we get in the output only DC while AC is being checked over here. In the other way, we can also say during the, when current is increasing, when current is increasing, inductor, the energy stored in the inductor in form of the magnetic field. When current decreases, then stored energy is released in form of the current, and so the fluctuations are maintained, are minimized. These fluctuations are minimized. So this way, by storing and releasing the energy, the inductor smooths the current. This is series inductor filter. The second one is shunt capacitor filter. Shunt capacitor filter. Here to the rectifier circuit, we use a high value capacitor. This is the rectifier circuit. We use a high capacitor, high value capacitor in parallel with the load resistance. In parallel to the load resistance. High value capacitor we use. How it minimizes the fluctuations? As we know that capacitive reactance of the capacitor can be given as in 1 upon 2 pi Fc, 1 upon omega C, yeah 1 upon 2 pi Fc. So if frequency is high, then Xc will be low. It will offer the low resistance to the high frequency AC. But if frequency is low, it will offer the high resistance. For the DC, whose frequency is 0, it offered the infinite resistance. So when there is coming an AC plus DC mixture, then to the DC it will block. It will not allow to pass. So DC will pass straight and will drop across the RL. But AC, it offers the low resistance, so AC will bypass through the capacitor and back to the circuit. So this way, it checked the AC to reaching the RL by bypassing it. In the other way, we can also say, like again, as an inductor, as current is fluctuating, AC is fluctuating. So when current is increasing, this capacitor gets charged. When current decreases, this capacitor gets discharged. Send the current back to the circuit. It discharge and send the current. Again, when current increases, it charge. Again, when current decreases, is discharge and send the current. So result is that we remove this fluctuation. So current is almost in smooth current. Is fluctuation has slightly decreased. So this way, the capacitor or inductor offer the provide smooth DC in the output by bypassing or by blocking the AC component. We call them filter circuit, right?